Have you ever wondered what's really holding our digital world together? You know, from your banking app to your university portal, there's this hidden plan, a kind of secret blueprint that dictates how it all works. Well, today we're going to make that invisible blueprint visible. Let's pull back the curtain on the world of system architecture.
You know, this quote just says it all, doesn't it? You never think about a building's foundation until the walls start cracking. It is exactly the same with software. When an app is fast, reliable, you just use it. You don't think twice. But the moment it crashes, or maybe your data disappears, oh yeah, you are feeling the effects of a failed architecture.
So, to really get this, we first need to define what this invisible blueprint actually is and why it's probably the most critical part of any system you use. Right. It's the question that sits at the very heart of every single digital product. Is it the code? Is it just a diagram on a whiteboard? What is this thing, really?
Okay, think of it like this. If you're building a house, the architecture isn't the brand of hammer you use or the color of the paint. Nope, it's the master plan. It dictates not just what goes where, but how everything connects, and this is the important part, why it's built that way. It's the fundamental logic of the structure itself. But here's the thing, architects don't just pick a design out of a hat. Their choices are guided by very specific needs, and boy, do they involve making some really tough decisions. So what forces their hand? It's so easy to get caught up in the latest trend or what seems popular at the moment. But solid architecture? It's not about chasing fads. It's about choosing the right tool to solve a very specific problem, whether that's handling millions of users or protecting super sensitive data. At the end of the day, the needs of the system, they're the true boss. And these needs, they usually fall into three main camps. First, you've got business drivers. That's the big picture stuff, like how will this system help the company grow? Then there are functional drivers. What does the system actually have to do? Like letting different departments access the same data. And finally, you have quality drivers. This is all about how well it needs to do its job. Does it need to be ironclad secure? Does it need to be lightning fast? And this is where it gets really tricky. I mean, we all want an app that's super easy to use, right? But we also demand that our money is completely, totally secure. These two things are often in direct conflict, and that forces the architect to make what's called a trade-off. This is the constant balancing act an architect has to perform. If you add more security, like multi-factor authentication, well, that might add an extra step for the user, making it a little less convenient. If you want to squeeze out every last drop of performance, you might need some really expensive hardware, and that drives up costs. Architecture really is the art of navigating all of these competing demands. Okay, so given all those drivers and trade-offs, what are the actual blueprints an architect has to work with? Let's break down three of the most common architectural patterns you'll see out there. First up is the classic layered architecture. I want you to think of it like a layer cake. Each layer has a very distinct job, and they're all stacked on top of each other in a super organized way. This creates a really clear separation of concerns, which is fantastic for control and maintenance. Now, this diagram really shows you how it works. A user's request comes in at the top, at the presentation layer. That's the user interface, what you actually see and click on. It then passes down to the business logic layer, which is where all the real thinking happens. And finally, it hits the data store layer at the bottom to get or save information. It's incredibly structured, very predictable, which is why organizations that need a lot of control and compliance, like government agencies, often love this model. Next, we've got service-oriented architecture, or SOA for short. Now, instead of one giant system, SOA breaks down business functions into reusable services. Just imagine having a single payment service that every single department in your company can use, instead of each one building their own from scratch. And this diagram shows it in action. See, you have a central service repository. Think of it like a library of all the available business functions. When an application needs something, it doesn't build it. Instead, it sends a request to the service bus, which acts like a traffic cop, finding the right service in that library and connecting the two. This is amazing for integrating complex organizations where tons of different systems all need to talk to each other. And finally, we get to microservices. This basically takes that SOA idea and just pushes it even further. A system gets broken down into a whole collection of tiny, completely independent services, where each one handles just one specific business capability. That's it. Just look at how granular this is. Instead of one big system, you have tiny, separate services for literally everything. One for user notifications, another just for processing profile pictures. The really powerful part here is the API gateway at the front. It takes all the client requests and routes them to the correct little service. This means you can update or fix or scale just one piece of the puzzle, say the notification service, without touching anything else. It gives you incredible flexibility and speed. So, let's put them side by side for a second. The key difference really boils down to scope and goal. SOA is thinking big. It aims to integrate an entire enterprise with these larger reusable services. Microservices, on the other hand, is all about building agile and scalable applications with tiny independent services. So yeah, they're related concepts, for sure, but they solve very different problems. Choosing a style is one thing, but how do we actually make all these different components and services and systems talk to each other? Well, that's where integration comes in. There are three main ways to do this. First, you've got data integration, which is all about the information itself. So think about making sure a customer's address is the same in the shipping system and the billing system. Next is process integration. This connects entire workflows. For example, when the sales department marks a deal as closed, it could automatically trigger a process in the finance department to create an invoice. And finally, there's API integration. This is where systems talk directly to each other, like when your ride-sharing app uses the Google Maps API to show you a map. All right, enough with the theory. Let's see how all this stuff actually works in the real world. We're going to look at a couple of scenarios and figure out the best architectural fit for each one. So first up, a university research system. The challenge here is pretty clear. You have multiple offices, proposals, ethics, funding, and they all need to see and act on the exact same information. So what's the right blueprint here? Well, it's got to be service-oriented architecture. And why is that? Because the core problem is integration across all these different functions. By creating a separate proposal service, an ethics service, and so on, the university can make sure every office is working together completely seamlessly. And for our final case, a brand new startup. Their whole world is about speed. They need to be adding new features every week, handling unpredictable growth, and be ready to pivot on a dime. Honestly, their survival depends on being flexible. The clear winner here is microservices, no question. The ability to update one small part of the platform without having to deploy the whole thing is an absolute game changer for a startup. It gives them the speed and the agility they need to compete. And this really brings us back to the main idea. There's no single best architecture. There's only the one that is the best fit for the job you need to do.